Let's talk about the perimeter and area of circles and regular polygons. This is the vocabulary you need to know. Most of this you should already recognize, especially with the circle. But we're going to be learning new vocabulary words like the apothem and the essential angle of a regular polygon. A circle is the locus of points in a plane that are fixed distance from a point called the center of the circle. Basically, you have the center and all of these points that are equidistant around this circle because we know that all the radii are congruent within the same circle. And of course, you can't go by my drawing. But a circle is named by this symbol, a circle with the center, and its center. So in this case, if it has circle A, we should have an A right here at the center. The radius here is AB. The diameter would be CD if you know that this goes straight through the center. So there's point D. And hopefully you recognize the formulas for circumference and area. The circumference is pi times diameter, or 2 pi r. The area is pi r squared. Remember that circumference is the same thing as saying the perimeter of a circle, but we just call it the circumference. Let's look at an example. We want to find the radius of circle J if the circumference is 55x plus 18 pi meters. So we're dealing with circumference, which means, and we're given, or finding the radius, sorry. So circumference is 55x plus 18 times pi. Our formula, since we are finding radius, let's use 2 pi r. Substitute in what we know. It is important that you recognize there is a pi with it so that you don't forget to put it in the formula. Because now to solve this, we can divide both sides by 2 pi. And by doing that, the pi's simplify. We have to divide 55 by 2 and 18 by 2 to where we get an answer of 27.5x plus 9 meters as our radius. Looking at this one, it wants us to find the circumference, but now it gives us the area. So if you think about the area and how to find it, we have to use the formula pi r squared. So we make our list to where we have 49x squared pi, and we need to find the radius. So when we substitute in, we need to work on getting r by himself. And so to get r by himself here, we have to square root both sides. Square root of 49 is 7. Square root of x squared is x. So the radius is 7x feet. Now, but remember, it wants us to go back and find the circumference. And since we are given the radius, let's use circumference equals 2 pi r. Plug in our radius. And now we can simplify, and we get 14 pi x feet. So make sure that you are reading the question and answering what it is asking for. On this next one, this is the question I want you to do in your notes for discussion in class. Make sure to read it and answer the question. Let's talk about regular polygons. The center of a regular polygon is equidistant from the vertices, similar to a circle. The apothem is the distance from the center to a side. And we also have a central angle of a regular polygon, which is the vertex of the angle is at the center, and its sides pass through consecutive vertices. So each central angle measure of a regular n-gon is 360 divided by n. So looking at this figure down here, we have a regular pentagon, because there's 5 sides, Point C is our center. CB is our apothem. And angle FCE is the central angle. And hopefully now by seeing a diagram you understand why to find the measure of the central angle we do 360 divided by n, the number of sides. Let's take a look at an example. Oh, I guess you need to know the formula first. It's the area of a regular polygon is 1/2 the apothem times the perimeter. Remembering that the perimeter is you are adding all sides of the polygon. Now let's look at an example. We want to find the area of a regular heptagon. So here we know n equals 7 with side lengths 2 feet to the nearest tenth. So we need to write our formula and make our list of variables. And notice there is a capital A and a lowercase a, and it is important that you write them that way. Capital A is our answer, the area. Our apothem is that segment that goes from the center to the side. And then our perimeter. Our perimeter we already know because there are 7 sides in a heptagon times 2 feet, so our perimeter is 14. Now we got to think about how to find the apothem. I'm going to pull out one isosceles triangle from inside the heptagon. To find the central angle, remember I do 360 divided by n, in this case, which is 7, and I get it's about 51.4 degrees. So this angle is 51.4 degrees. The apothem goes from the center of the heptagon and is perpendicular to the side. This is our apothem. Right here, it cuts this angle in half, so 51.4 divided by 2 is 25.7 degrees. We know that the whole side is 2, which means each of these is 1. Now, if I were to pull out this triangle here, here's my apothem. This is 25.7. And this is 1. Hopefully you recognize that to find the apothem, we're going to have to use trig. So if this is the angle we're talking about, this is the opposite side, and this is the adjacent side. And we remember that that's going to be tangent. So we have the tangent of 25.7 equals the opposite over the adjacent. Make your proportion, and we cross multiply. So a times tangent of 25.7 equals 1. You must show this step. This tells you whether or not you multiply or divide. And in this case, we are going to divide. And we get that our apothem is approximately 2.078. Now we have enough information to substitute into our area formula. So 1/2 times our apothem times the perimeter. And we just type it in the calculator and we get that the area is approximately 14.5 feet squared. Remember it said to the nearest tenth. So this sounds like a lot of work, but the hardest part is figuring out the apothem when we're using our trig. From there, we're just substituting in. Let's look at one more example. Now we want to find the area of a regular octagon, so we know that n is 8 with the side length of 4 centimeters. So we know area equals 1/2 the apothem times perimeter. Make our list of variables. Perimeter, we have side length of 4, we have 8 of them, so we know our perimeter is 32. Pull out one of the isosceles triangles within the octagon, and the central angle is 360 divided by 8, which does give us 45 degrees. Draw in your apothem. Remember the side length was 4, which makes this one 2. Cuts the angle in half, so 45 divided by 2 is 22.5. So if you want to draw that one right triangle, here's your apothem, here's the 2, and here's the 22.5. Be careful not to use the 45-degree angle for your special right triangles because we did bisect that angle. So now, here's our angle, here's the opposite side, here's the adjacent side, and we are using tangent. So tangent of 22.5 equals the opposite over the adjacent. Make your proportion and cross multiply. You recognize that we are going to divide by the tangent of 22.5. Oop, I left off my tangent. And when you type it in the calculator, you get that your apothem is approximately 4.828. The farther you round, the closer the answer is going to be at the end. So now our area is 1/2 the apothem times the perimeter, which gives us that the area is approximately 77.3 centimeters squared. If you don't understand this process, you could recognize that you have isosceles triangles within the polygon, and if it's an octagon, you have 8 of them. So you could actually find the area of one triangle and multiply by 8 and you get the same answer. But remember, you still have to find the height of the triangle, so you're still going to be involving trig.